These are images from space, slices of the universe put under a microscope, images of new life and haunting images of destruction. They may give us clues about our place in the cosmos, where we came from, and where we're going. These are images from the Hubble Space Telescope. Orbiting just 330 miles above Earth, its view extends for trillions of miles beyond our corner of the universe to unlock secrets from space. Like an undersea creature roving the depths of the ocean, Hubble is perfectly adapted to the alien environment of space. For 15 years, it will soar above Earth's atmosphere to record the violent, often cataclysmic events taking place in the heavens. The death of stars, the birth of planets, the gluttonous appetite of black holes, the vital stardust that feeds solar systems, and life itself. We may even get a glimpse of what's in store for Earth in this erupting, exploding landscape of space. Astronauts sent into space to service the telescope cannot help but admire Hubble.
It's not only such a powerful instrument, but it's such a beautiful instrument. It's a very, very strong symbol of humanity's quest to find humanity's place in the universe.
With its 400,000 parts, Hubble needs a tune-up occasionally, just like a car, once every 500 million miles. Astronauts are now training for a look under Hubble's hood to install more powerful cameras. While the real Hubble orbits high above Earth, these models on the ground prove, if anything, that the telescope is big.
I'm standing next to a full-scale mock-up of the Hubble Space Telescope. It stands about 45 feet tall, which is equivalent to a 4-story building, and weighs about 25,000 pounds. It's not the largest telescope or telescope mirror in the world, but because it's orbiting in space above the atmosphere, it produces pictures 10 times clearer than any telescope on Earth.
So clear, in fact, that if Hubble sat atop the World Trade Center in New York City, it could see a dime on top of the Washington Monument. From the monument, Hubble could span the continent to the California coast, where it could easily read the signs of Hollywood, large and small. But these aren't the stars Hubble is looking for. These are actual pictures Hubble has sent back from space. All these pictures are, in a sense, dated. They don't represent the present-day activities of stars and galaxies. They can't, because light, the light that makes these pictures, can only travel so fast through space. Light from our star, the Sun, takes 8 minutes to reach us on Earth, 90 million miles away. But most objects Hubble studies are so far away, it takes their light thousands, millions, even billions of years to reach the telescope and us. This exploded star left us a cosmic rose as it throws off its outer layers in an intricate dance. 3,000 light years away from Earth, we are seeing the Cat's Eye Nebula as it was 1,000 years BC. Eta Carinae, its light took 9,000 years to reach us. That means it is 9,000 light years away. The last outburst from this stellar bad boy was seen in 1843, when it became the second brightest star in the sky. With the delicate appearance of blown glass, this is the Hourglass Nebula. Hubble sees the hourglass 8,000 light years away, as it was when mankind still lived in the Stone Age. So Hubble is, in essence, taking pictures of the past. Astronomers can sift through these fossil records like archaeologists, searching for clues to what took place when the universe was a younger age.
We've always been interested as a species, maybe more than interested, obsessed with the idea of where did we come from, how do we fit into this universe? But science is giving us a whole new method of discovering, reading from what's written in the stars, where we actually came from.
The story of the telescope's namesake goes back to Southern California in the 1920s. Early in the 20th century, astronomers still believed that the universe consisted of our Milky Way galaxy and nothing more. That concept was shattered by a dapper young astronomer, a star athlete and Rhodes Scholar named Edwin Hubble. While working at the Mount Wilson Observatory, he made one of the greatest scientific discoveries of the 20th century. The universe is composed not just of the Milky Way galaxy, but of countless galaxies, and those galaxies are speeding away from each other because the universe is expanding.
Before Hubble, there was a lot of debate about the universe. The most current theory in those days was that the universe was steady state. That is, no matter where you looked in space or time, no matter how far you look back, the universe more or less looked the same. It didn't evolve. Hubble gave us an expanding universe, and his observations really led to today's modern cosmology.
Hubble found that not only were the galaxies speeding away from each other, but the further away the galaxies, the faster they were moving away.
And it only takes a little thought to realize that a situation in which everything is moving apart from everything else, and the greater the distance, the more rapid the expansion, is just the situation you have if you start everything out with an explosive-like event and throw everything out. If you could run that movie backwards, you would see that everything came from one event, which we now refer to as the Big Bang.
Sharp observations made from a sharp telescope placed young Edwin Hubble next to the great minds of the century. A curious Albert Einstein, whose theory of relativity was partially confirmed by Hubble's observations, paid a rare visit to the astronomer's mountaintop. Hubble proved a telescope could look back in time to view the history of the universe. But that history would be muddled as long as telescopes remained grounded on Earth. Earth's murky atmosphere distorted the picture of space and blurred the truth. But a telescope above the Earth, that would give astronomers a clear way to see forever. Astronomer Lyman Spitzer proposed the idea for a space telescope in 1946, but many considered this a notion only for dreamers, science fiction.
I think almost all of my friends took a rather skeptical view of astronomical research out in space. They thought it was basically impractical, pie in the sky.
Pie in the sky or not, a telescope above Earth's atmosphere would provide amazing clarity. The space age provided the opportunity.
Oh, that view is tremendous. Roger, understand, go for at least 7 orbits.
During the Cold War, the space race heated up. Spy satellite technology was designed to look down, not out, gathering secrets from the Earth. Astronomers wondered, what greater secrets could be revealed if the lens were pointed away from the planet?
I told some friend of mine that I was getting involved in a funded satellite program involving a substantial size telescope. And he looked at me and with a smile and said, "Well, Lyman, you're young. You'll live to see it fail."
The Hubble Space Telescope is the result of more than 20 years' work by some 10,000 scientists and engineers. Many of the scientists involved with Hubble dedicated major portions of their careers to the project.
It seems I've been involved for forever, and I wouldn't have done that if I didn't think that the payoff scientifically would be big.
T-10, go for main engine start.
April 1990, the launch of the Hubble Space Telescope, a payoff for almost a generation of labor.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
The hopes of thousands of astronomers ride into space on a trail of fire.
Discovery Houston, performance is nominal. Rendezvous, we're go. Fido, go. Eagle, go. Ecom, go. Inco, we're go. FAO, go. EVA, we're go. Sergeant, you're still go? Go. Capcom, we have a go for release. Discovery Houston, go for Hubble release.
Okay, Story, we've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to filter state.
Soon after deployment, Hubble would make front-page news all over the world, but it would not be the news the astronomers expected. Chris Burrows looked at the first pictures and knew something was wrong.
So, of course, we were very excited to see what the Hubble would finally produce. And the very first image we got was this. We were very glad to see that this double star had been separated into its two components, but each of the components was surrounded by fuzz, and that fuzz was the first hint that we had a problem with the optics.
The primary mirror of Hubble had been incorrectly ground by 1/50th the width of a human hair. This small error was enough to cripple the $2 billion telescope.
How could the science fail? How could there be a flaw? And what is it there about our system that doesn't identify the flaws until way, way, way late in the game?
Like many, it was one of the dark days of my life.
It was horrible. You know, I was new. I'd only spent at that point, maybe 5 years of my life doing that. Many people at that point had spent over a decade of their lives. And here, it just wasn't going to let us do the sorts of things that we had always hoped to do.
It was really a stain on the honor of the astronomy community and of NASA to have launched this very expensive telescope and to have this most fundamental of errors, spherical aberration in it.
The mirror is a beautiful mirror. It's got a lovely shape. It's wonderfully smooth. It's just the wrong shape. But because it's such a beautiful mirror, it was possible to build instruments that would use that wrong shape and still make good images.
Hubble would receive 2 sets of tiny mirrors, eyeglasses like these. The hopes and dreams for Hubble and for space astronomy would rest on this audacious proposal for a fix. December 2nd, 1993. The stage is set for the gutsiest shuttle mission in history, the rescue and repair of the Hubble Space Telescope. NASA has assembled a crew of its best and brightest, including the astronaut's astronaut, the payload commander, 59-year-old Story Musgrave, who brings his skills as a surgeon to the delicate operations ahead.
I am really frightened by this. I am both very scared and I'm very confident. If you ask me how it's going to turn out, if you force me to bet on it, I would bet on it that we would get everything done. This is a drama, and it's got to unfold.
How do you read this morning? Good morning, Dick. Got you loud and clear.
3, 2, 1. And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
The mission, 5 spacewalks in 5 nights to repair Hubble's delicate optics. While America is in an early winter slumber, the shuttle leaves behind the evening lights of South Florida. The main work on Hubble will all be done at night to protect the telescope's instruments from direct light. Direct sun could fry Hubble's innards.
We're ready to go grab that thing.
I bet you are.
While hurling around Earth, the 100-ton shuttle must track down and grab the 12-ton telescope. Once Hubble is in the astronaut's sights, the delicate task of reeling in the telescope begins. Story Musgrave reacts to his first sight of Hubble in space.
First reaction is how beautiful the thing is. It's just a gorgeous spaceship. You just look at it with respect. You look at it almost as if it has personality. I mean, it's awesome.
Endeavour has a firm handshake with Mr. Hubble's telescope.
We copy that, Cubby, and there are smiles galore down here.
It's quite a sight.
Hubble has logged some 500 million miles since it was last touched. With its multiple layers of insulation, Hubble weathers the extremes of space, searing heat in the sun, Arctic cold in the shade.
Sounds like a good plan, Endeavour. Good morning.
The astronauts float into this hostile landscape, a long list of repairs ahead. The blackness of space surrounding them makes it easy to forget this is a high wire act, 330 miles above Earth. Story Musgrave and Jeff Hoffman change out the telescope's wide field and planetary camera. This is Hubble's main camera.
Okay, easy to keep it centered. Just fingertips. Focusing it with my
A small mirror at the end. Stars are born.
You can accomplish